Welcome to homework.
In this question, we are asked to explain how Kw changes with increasing temperature, keeping in mind that the autoionization of water is an endothermic process. So let's try to write down a reaction that will help us understand the change in Kw with increasing temperature. So the autoionization of water is the reaction that is under concern right now. So liquid water can reversibly dissociate into hydronium ions in the aqueous phase and hydroxyl ions in the aqueous phase. So since this is said to be an endothermic reaction, heat is a reactant in this reaction. So heat will help the reaction move forward. So if we increase the temperature of this system, according to the Le-Chatelier principle, the reaction equilibrium will shift in the direction which reduces the temperature, right? So the temperature will increase if we go in the backward direction, and the temperature will reduce when we go in the forward direction, because heat is a reactant in this system. So for that reason, when we increase the temperature, there's going to be more of hydronium ions and hydroxyl ions produced, which means the Kw value, which is the product of the hydronium ion concentration times the hydroxyl ion concentration, is going to increase with increasing temperature. If these concentrations increase, Kw will increase with increasing temperature. Okay, let's look at the second part of the question. In the second part of the question, we are told that in medical applications, the value of Kw is used at 37 degrees Celsius, which is the body temperature, rather than 25 Celsius Kw value, which is 1.0 times 10 to the negative 14. So, and then we are asked to calculate the Kw value, the pOH value, and the OH ion concentration at 37 Celsius if the pH of pure water at 37 Celsius degrees is 6.8. Let's try to answer the second part of the question. So we know the pH of pure water is 6.8 at 37 degrees Celsius. And since it's pure water, the pH value will be equal to the pOH value. So one of the questions we are asked is to calculate the pOH value, and based on the pH value, we can predict that it has to be the same. And so the pOH is also going to be 6.8. So if we know the pOH value, we can calculate the OH ion concentration, because the OH ion concentration is going to be 10 to the power negative the pH value. So this will give us 1.6 times 10 to the negative 7 molar. So now we know the OH ion concentration, which has to be equal to the H plus ion concentration because the pH value is equal to the pOH value. So since we know those two, we can calculate the Kw, which is the product of the concentrations of hydronium ion and hydroxyl ions. And in this case, because they are the same, we can just take 1.6 times 10 to the negative 7 molar and square it. And this will give us 2.5 times 10 to the negative 14. So this is the Kw at 37 degrees Celsius. Let me just write that over here, 37 degrees Celsius.